This video covers Appendix A11 in the text, the Poisson distribution. The text doesn't provide a sample problem. However, it does present a distribution with 8 arrivals and a lambda, or mean, of 2. So I have just constructed a table that conforms to those parameters. If you want to work along, you will need to pause the video and copy these tables. Don't worry about the text, don't worry about this equation. They're just for instructional purposes. Try to put these values in the same cells so that your formulas will match my formulas. As I work through this, I'm going to solve this using the equation that we're provided, and then I'll solve it using the Poisson dist in Excel. First of all, let's solve it using the equation. And again, an easy way to solve equations in Excel is to take the elements of the equation, put them in a column, solve for each, and then conduct the indicated operation, multiplication, division, whatever. And we're also going to have a cumulative column here where we'll calculate a cumulative total. Let's begin here with arrival 0. And arrival 0, you see it's lambda to the x. We have lambda here, so I'll make that absolute, a lambda of 2. And I'm going to raise that to the x power, which is the arrival, and I'll just leave that relative. So I'll just copy that down then. That will give me lambda to the x for each of my arrivals. Then I want e, and I'll go ahead and calculate e. E is a compounding constant that we use a lot in finance to calculate continuously compounding interest rates. And it is calculated in Excel by using the exp function to the first power. That will give you e. I require that you find e this way. Even though it only shows 2.72, it's calculating e out to about 17 places behind the decimal, and it's using that numerical calculation. So if you just type in 2.72 here, you'll get the wrong answer, and we'll have to mess with that on the exam and homework assignments. So use this formula in Excel when calculating e. So we're going to raise e to the negative lambda here. So let's just go ahead and do it. It's going to be the same value for each value of x, but we'll do it just as an exercise here. E will make that absolute, raised to the negative lambda, which we will also make absolute. And just copy that down. Now the next step, we will take lambda to the x and multiply it times e to the negative x, just following our heading there. Copy that down. Now we want x factorial. In Excel, we find the factorial equals fact, and then we give it the value of x that we want. And factorial is just for 0, it's 1, and for 1, it's 1. But for 2, 3, 4, 5, and 6, for 4, for example, it's 4 times 3 times 2 times 1, and you get x factorial. Excel does that for you very quickly. It's a lot easier than trying to do it yourself. Now we'll go ahead and put it all together and find the probability of each instance of x, each arrival. We'll take our value here and place it over our value here, and that gives us the probability of 0 arrivals all the way down to a probability of 8 arrivals. Now we'll calculate our cumulatives so that we can state the probability of less than 2 arrivals or more than 4 arrivals, so on. So we'll just go ahead and, for our cumulative, we'll Cumulative for 0 is simply 0. The cumulative for the next value is the previous cumulative value plus the current probability. And we can just copy that down. You'll notice that this doesn't equal 1. In the Poisson distribution, we have a probability of 9 arrivals, 10 arrivals, 11 arrivals. We could have an infinite number of arrivals, and so that would continue to carry out, always getting closer to but never reaching 1. And that's how you solve it using the formula. Now let's solve this in Excel, and I recommend that you do it this way. Why go through all of these steps, risk making a mistake when you can use the Poisson.dist function in Excel? So the probability of x using the PoissonDist function, the PoissonDist function wants to know x. It wants the mean, which is lambda in the Poisson distribution. We'll make that absolute. Now, keep in mind, that's not the case in the exponential distribution, which we'll talk about later, that also uses lambda. Lambda and mu are not equal in the exponential distribution. Lambda is 1 over mu. It's the reciprocal of mu. So just a reminder, in the Poisson distribution, the average and lambda are the same thing. Now, the Poisson distribution is a discrete probability distribution. It is possible in discrete probability distribution to find the probability of an exact value, whereas in the continuous distribution, like the normal distribution, it's not possible. That the probability of an exact value in the normal distribution is 0. So we always answer true to this question. However, in a discrete distribution, when we want to find the probability of a discrete instance, so the arrivals of 0, we answer false. And that gives us, the description here is the probability mass function, but that's simply the probability of x. So the probability of 0 arrivals, answer false to that question, and that gives us the probability. You'll notice that it matches. And if I copy that down, you'll notice that each of these instances all the way down match our calculation here. Now, to find the cumulative using the Poisson.dist function in Excel, we just take Poisson.dist. We get our x value again. We get our mean value, which we have to, our lambda, which we have to set to absolute. And this time, we answer true to the cumulative question, and that gives us the cumulative total, so up to and including that value of x. And if we copy that down, you'll notice that each of these values equal these values that we calculated here. That's how you find the probabilities of arrivals using a Poisson distribution, using both the formula for the Poisson distribution and the Poisson.dist function in Excel.